Now in this lecture, we are going to look at InOrder traversal in case of binary search tree. Now in case of InOrder traversal, as we said before, first we are visiting left subtree, then the root node, then the right subtree. So in this case, in case of this binary search tree over here, first we are going to start from this left subtree, then we are going to continue to the root node, then we are going to continue to the right subtree over here. Now when we are visiting left subtree, we can easily see that we have another left subtree inside this left subtree over here. So this means that whenever we are starting, we are going to start from this smaller left subtree over here. Now in case of this binary search tree over here, if we traverse this binary search tree using InOrder traversal, the order of traversal will be like this. So first we are going to start from 20, which is left child, then root node, then the right child, which is 40, then the root node, then the right child, then again root node, then the left and the right, and root and right child. So here you can see that for each subtree over here, we are implementing same logic. So this means that for this smaller subtree over here, we have implemented same logic. First we have visited left child, then root node, then the right child. Then for this left subtree over here, first we are visited left subtree, then the root node, then the right child. Then for whole binary search tree over here, you can see that after finishing left subtree, we are continuing to the root node, then right subtree. So the same logic is implemented for right subtree over here. First we have visited left child, then root node, then the right child over here. Now this is how the logic of InOrder traversal works in case of binary search tree. Now based on this logic, let's head over to Java and create our InOrder method over there. Now here, after pre-order traversal, I'm going to create InOrder traversal method. So it's going to be like this: public void InOrder. So as a parameter, this one also will take the type of binary node. So I'm going to name the parameter node. So here again, the first thing that we are going to do, we are going to check that if node is null, in this case we need to return because this is our base condition. It means that we have reached the end of the binary search tree. Then after this if condition, we are going to write our logic. So as we said before, first we are visiting left subtree, then the root node, then the right subtree. Now here, after if condition, we are going to call our InOrder traversal method for left child. So because in case of InOrder traversal, first we are visiting left child, then the root node, then the right child. So here I'm going to put it like this: InOrder. So it's going to be node.left. Then after doing so, we are going to print out the value of the root node. So I'm just going to copy it from the pre-order traversal and put it over here. And then we are going to call InOrder traversal one more time recursively for right child. So with this, we have successfully implemented our InOrder method for binary search tree. Now let's see how this is working in practice. So here we have created a binary tree like this. This is the tree that is shown in this picture over here. Now in this picture, you can see the order of the visit of the elements in case of binary search tree when we call InOrder traversal. Now if I call InOrder traversal for this binary search tree over here, if the output is same as the order that is shown over here, it means that our method works the way that it should be. So if I run our code, so in this case, you see that first starting from the left subtree, then the root node, then the right subtree. So the order over here is same as the order that is shown over here. So this means that our InOrder method works the way that it should be. Now let's see what's the time and space complexity for this method. Now it's obvious that the time complexity will be O(n) because in this case we are visiting all nodes of binary search tree and printing out their value. So this means that if the number of elements in the binary search tree is O(n), so the time complexity for this InOrder traversal will be O(n) time complexity. Now similarly, space complexity is also O(n) because in this case, when we are calling a method recursively for left and for right child, in this case we are inserting all nodes to the stack memory for remembering them for the next calls. So that's why it will take O(n) space complexity. Now with this, we have come to the end of this lecture. So in this lecture, we have discussed InOrder traversal in case of binary search tree. So hopefully everything is clear about this method also. Now in the next lecture, we are going to talk about post-order traversal. So see you in the next lecture.